This is section 5.5, which is the law of sines. We're going to talk about deriving the law of sines, solving triangles that are angle, angle, side, angle, side, angle. We're going to talk about the ambiguous case, which is side, side, angle, and we're going to talk about application. So these last two sections cover law of sines and law of cosines. And law of sines and cosines are the answer to the question, what do you do if you need to solve a triangle that is not a right triangle? So everything we've done up until this point has been involving right triangles. But we know in real life we have triangles of all different types. So law of sines and law of cosines allow us to solve triangles that are not right triangles. So we have if triangle ABC has angles A, B, C, opposite sides A, B, and C respectively, then the ratio of the sine of the angle over the side is equal for A, B, and C. It's important to note when you are drawing your triangles, it doesn't matter where you place your angles, like angle A, B, C, but what does matter is that the angle, the capital letter angle, opens up to the side of the same letter. So little a needs to be opposite angle A, little b opposite angle B, and little c opposite angle C. So you use capital letters to note the angles, lowercase letters to show the sides. So our first example, we're solving a triangle given two angles and a side. So we have angle A is 38 degrees. I'm going to draw a triangle here. So I'm going to put this A, B, C. Again, doesn't really matter where we put these, but so this is 38 degrees. Side A is 9. Angle B is 46 degrees. Okay, so if you look at this picture, so if you think back to geometry when you talked about triangle congruency, you talked about things like angle, angle, side, angle. So this triangle right here is what we would classify as angle, angle, side. So anytime you have two angles and a side, you can use law of sines. So for this one, the first thing that we would want to do is we can find the third angle. So anytime you have two angles, remember a triangle is 180 degrees. So if I want to find angle C, I can just take 180 minus 38 minus 46, and that gives me 96 degrees. So I can put 96 degrees in there for C. So when it says to solve a triangle, it means to find all the missing pieces, find all the missing angles and sides. Okay, so now I'm ready to use my law of sines. So I always want to use the given, so that way if I make a mistake halfway through, I'm not making a mistake for all my answers. So I want to use sine of 38 over 9. Those were my givens. And let's start with side B. So I'm going to say sine of 46 over B. So then we just cross multiply. So we take 9 times the sine of 46 and we divide by the one left out. So we divide by sine of 38. And that gives us, for B, we get 10.516. Just be careful when you're doing the assignment that you're rounding to the correct place value. Okay, then I'm going to go back and use the same given to find C. So I'm going to say sine of 38 over 9 is equal to sine of 96 over C. Again, cross multiply and divide, and we find out that C is 14.538. Okay, so that is kind of the basics of law of sine. Now we're going to talk about the ambiguous case. So you probably learned that if it's angle, side, if it spells a bad word, then it is not a congruency that we used in geometry. But the reason is we can still use side, angle, but we need to understand that it's what we call an ambiguous case, because there's a possibility that we could have two triangles, there's a possibility we could have one triangle, and there's a possibility we could have no triangles. So I'm going to give you an example of all three of those situations so you can see. So I included the pictures on this one. Part of the hard part about ambiguous case is actually deciding which situation it is. So I'm going to show you that. You wouldn't normally have the pictures here to determine that. but it's just easier to kind of demonstrate how you can see that side AB can swing either wide to make an acute triangle, or it can swing in to make an obtuse triangle. So how we would approach this, we wouldn't, like, let's say we would just draw this triangle on the left, and we're not sure yet if it's one case, no cases, two cases. So we're going to draw this triangle, and then I'm going to start by trying to find angle A. Okay, so I could set this up as sine of 25 over 8 is equal to sine of A over 12. Now this one's going to be a little bit different because you're going to take sine of 25 times 12, and then you're going to divide it by 8. And you're going to get a decimal, a small number. But remember, we're solving right now for sine of A. So sine of A is 0.6339. So then in order to find angle A, I would do the inverse sine of 0.6339. I'll actually keep the whole answer in my calculator, so I'm not rounding until the end, and we get 39.3 degrees. Okay, so that means that angle A right here is 39.3. It's hard to write tiny. Okay, so now how you determine, so once you find that first angle, you're going to want to determine, is there only one triangle or are there two triangles? So we know there's at least one because we got a valid answer here. So to determine if there's a second triangle, what you want to do is, we know that with sine, we know that there's two values. So even though our calculator just gives us 39.3, there's another value of sine that is less than 180 that will have that same sine value. So we find that by taking 180 minus 39.3. And if we take 180 minus 39.3, we get 140.7 degrees. So that is potentially our other angle A, okay? But now the way that we check is we're going to say, okay, does this triangle make sense? So let's try to find angle B. So I would take 180 minus 25 minus 140.7. And I get, for angle B, I get 14.3. If you were to get a negative number when you did that, then it would be not a second triangle. But since 14.3 is valid, that means that we do have a second triangle. So we're going to solve each triangle. After you find that initial one, we're going to solve each one separately. So we've already found over here, that's our obtuse angle A. That's angle B. Okay, and over here, this is our angle A. So we found angle A. We can find B using 180 minus 25 minus 39.3. And we get, what do we get? 115.7. Okay, and then finally on both sides, we're going to do law of sines to find side B. So I would do sine of 25 over 8 equals sine of 115.7 over B. And we cross multiply and divide, and we're going to get 17.06. And then over here, we're going to do the same thing. Sine of 25 over 8 equals sine of 14.3 over B. And we get that B equals 4.68. Okay, so this again is what we do if there's two triangles. And you figure that out by first finding your first angle, taking 180 minus that, and then checking to see if another triangle would work with those angle values. And this might make more sense when we go through the other two ambiguous cases too. Okay, so our second situation, okay, is, so we have an angle and two sides. So I'm going to set up my triangle here. So we'll say A right here is 30 degrees. Side A is 7. I'm going to make this angle B. That's 6. Okay, so first thing I do is I'm going to find angle B. So I'm going to say sine of 30 over 7 equals sine of b over 6. So I cross multiply and divide, and then I do the inverse sine, and I get the angle B is 25.4 degrees. Okay, so we're going to check for second triangle. Okay, so the way I would do this is I would say, okay, my obtuse angle B would be 180 minus 25.4, which would be 154.6 degrees. So that would make our angle C 180 minus 30 minus 154.6. And that would equal negative 4.6 degrees. That is not possible. So therefore, there's no second triangle. So that's how you determine. So it worked for us in the last problem. It didn't work here. So that means we only have one triangle we need to worry about, and then we continue to solve that one triangle. So we found that B is 25.4. We can do 180 minus 30 minus 25.4, and we get that C is 124.6 degrees. And then we can do law of sines, cross multiply and divide, and we would get that side C is 11.5. Okay, so that's a situation where there's only one triangle, but you can see how we checked and it didn't work to have a second one. Now the third ambiguous case, okay, is we have, so we're going to check this. So we have angle B. I always like to put my angle in the lower left-hand corner no matter what letter it is. That's just my habit. Okay, so angle B is 20 degrees, side B is 3, side A is 12. Okay, so I'm going to find my angle A. That's my first step. So we're going to take sine of 20 over 3 equals sine of A over 12. So when you cross multiply and divide, you get that sine of A equals 1.37. And if you try to do the inverse sine of 1.37, we know that sine only goes between -1 and +1. So we can't take this inverse sine of a number that's bigger than 1. So this would give you an error on your calculator, and that means that there are no triangles. And what that actually looks like is, if you think about it, it's like that's a better illustration of this. You have that side hanging there, your angle's fixed, your side of 12 is fixed. There's no way to connect that triangle. So that would be the no triangle situation. Okay, our last example is an application problem. So it's finding the height of a pole. It said a road slopes 15 degrees above the horizontal. So here's our road. Okay, and a vertical telephone pole stands beside the road. So this right here is our vertical telephone pole. The angle of elevation of the sun is 65 degrees. So this angle right here, here's the sun up here. Okay, and the pole casts a shadow of 15-foot shadow downhill along the road. So this right here, it's labeled, but it's kind of off to the side. So that distance of the shadow down the road is 15 feet. It says to find the height of the pole. So the x distance is what we're trying to find. Okay, so we can fill in some more of these angles. So we know from back to geometry that these are vertical angles. So this right here is 65 degrees. So that means that this angle right in here would be 90 minus 65, which would be 25. Okay, and then we know that the this angle, this whole big angle right here, is also 65 because those are same side. Okay, no, they're corresponding. Okay, it's been a while since I taught geometry. Okay, they're corresponding angles. So that whole angle is 65 degrees. So that means we would take 65 minus 15 to get that angle right there, which is 50 degrees. Okay, so now we have those two angles. So we can set up law of sines. So we can say sine of 25 over 15 is equal to sine of 50 over x. And so if we cross multiply and divide, we get that x is 27.2 feet. So that's kind of an application problem of law of sines.